All right, tonight's lesson is exponential functions, and these graphs have a couple different parts to them, and we bring in a completely different word that you have kind of seen before, but you've never seen it as the actual word. So let's deal with y equals 2 to the x. What makes this an exponential function is having the variable in the exponent. If that would have been like x to the 5 or something like that, it wouldn't have been an exponential function. When we have our variable as this, it changes what the graph looks like. The way to graph these is essentially just to go ahead and make a chart. So an XY chart. The X is the number that we're plugging in here, and the Y would be whatever answer we get out. So let's go and pick 0, 1, 2, and 3. So we'll start with these. Keep in mind the bigger numbers that you use, the bigger your graph is going to get because the number that you're using is an exponent. That's why I use a 2, which is a smaller one. But if you pick a number like 10 here, 2 to the 10 all of a sudden gets really big and it makes your graph really big. So we go and plug the 0 in for this. So it becomes 2 to the 0, anything to the 0 power is 1. Then we got 2 to the 1, which is 2. We've got 2 squared, which is 4. And we've got 2 cubed, which is 8. These are the points that we're going to go and use to graph. So let's make a graph. So I'll go and use this one for right now. Notice that I didn't really make a negative y, the negative y on the graph. Don't really need it, and you'll see why in a minute. Start off with 0 and 1. There's our first point. 1 and 2. 2 and 4 brings us up here. And 3 and 8 brings us all the way up to here. Now, if you follow these points, you get this. When I was looking at some of your homeworks, some of you knew exactly what to do and you had all the numbers down and knew exactly which ones to pick. Hopefully, you get the same grades on your quizzes. For a lot of you, though, this is what I saw. And these would be the reasonable numbers to pick, especially if you didn't really understand what you're doing. When you look at this, you just kind of see this curve that's going up real fast. So if you ever hear the phrase, this is going up or going down exponentially, it's because it generally starts off slow and then gets much faster really quick. Now, the part that you're missing is all of this over here. We didn't pick any negative x values, and that really takes away a big chunk of the graph that you don't get to understand without seeing that, and a lot of the concepts that we're doing. So let's go and throw a couple more numbers in. Let's put in -1 and -2. So we've got 2 to the -1, which, keep in mind, the negative exponent, we make it 1 over, so this becomes 1 over 2 to the 1, which is just 0.5. And then you've got 2 to the -2, which is 1 over 2 squared, which is 1 over 4, which is 0.25. And if you want, you can check those in the calculator real quick, or you can just trust me that they work. Now we go and plot these. -1 and 0.5 kind of puts us right there in the middle. And then -2 and 0.25 puts us even a little lower. Now what you notice is this graph comes like this. But what it's actually going to do is no matter what numbers we pick, we're always going to have a number bigger than 0. It's never going to get to 0, although it's going to get really close. You can keep playing and pick a couple different negative numbers to go here. It's going to get down to like 0.00002 or something like that, but still not going to hit 0. It never will. So what that does is it introduces a new concept. I had to pause it there because there's no way I was going to be able to spell that word right. Y'all know how well I can spell. The word is called asymptote. What it is, it's a place on the graph or a line So an asymptote is going to be a line on your graph, and different graphs have asymptotes that go vertically. Ours, in this case, goes horizontally. Some of them even go diagonally. Some of them have more than one asymptote. Ours is only going to have one. It's going to be horizontal, and it's a line that our graph is getting close to but never touching. So we're getting closer and closer to that x-axis, but we're never actually going to hit it. So we would say our equation for our asymptote is y equals 0. Now, a little bit of a hint for all the ones that are like this that we were doing in this section, it's going to be y equals 0 for all of them. The only time that this is going to change is if this graph is shifted up or it's shifted down. If there's no transformations, yeah, there's that word again I told you would keep coming up, transformations. There's no transformation, so like a +2 or a -5 at the end of this, your asymptote is always going to be at y equals 0 for these. Now, a couple other key features that you need to know. Your y-intercept, that's still the same y-intercept that we've been talking about the whole entire year. In this case, the y-intercept is at 1. And the last thing to bring back is domain and range. For these, the domain is always going to be all real numbers because this one goes on to the left forever and it goes on to the right forever because this is going up at a bit of a slant. So your domain is always going to be all real numbers. Now your range, and again, that's all your values. It's wherever your graph is in respect to the y. All of our whole entire graph, the red here, is all above this line right here. Nothing is below it. So our range is going to be y is greater than 0. And notice I didn't put an or equal to underneath it because this line right here of the x-axis, or y equals 0, is an asymptote. So it's not going to actually hit that. So we can't put the or equal to because it's not going to be equal to 0. It's always going to be bigger than 0 in this case. And this is the way you graph the exponential functions. If you have any questions, send me emails in Edsby and we can figure it out.